So now we're going to look at another kind of a little bit more complex way that recursive definitions can be written. And that's where you base it off the previous two terms or more, not just the previous one term. So one of the most well-known sequences is the Fibonacci sequence, which is defined recursively using two previous terms. Its definition is given below. So this looks kind of weird. I mean, we have F's instead of A's, but I'm going to leave them because it's still subscript. So I think it kind of works the same way. So right now, I know F of 1 is 1, and F sub 1 is 1, and F sub 2 is 1. So basically, when I look at this, it means start with 1 and 1 for the first two terms. And then to get the next term, add the last term and the one before it. I'm going to write add the previous term, actually. By last, I mean previous, but that's probably a little more exact if I write it this way. And one before. Okay. So we're going to generate f of 3, f of 4, f of 5, and f of 6. So to get f of 3, I could do this in my head, but we're going to really write it out. So if I make this n a 3, n minus 1 will be a 2, and n minus 2 will be a 1. So if I add these two together, let's color code this. Right? So my f of 2 is 1, right? And my f of 1 is also 1, right? This is the first term. F of 1 is 1. So if I add those two together, 1 plus 1 equals 2. Okay. So now to get the next one, f of 4, I am going to add f of 3, right? So if this is a 4, this is a 3, right? One smaller. I don't know where this color coding is going, to be honest with you, but we're gonna stick with it. Okay. So then 2 before the 4 is 2, right? So this would be 4 minus 2 is 2. So if I go back up to my list, the third term is a 2. The second term is a 1. So the next term that we found is a 3. Now, at some point, you the whole point is like, right, we're using our brains. So I added the 1 and 1 together to get the 2, right? And then I added the 2 and 1 together to get 3. So you should start to recognize, hey, what am I going to add together next? I'm going to add together the 2 and 3 to get the 5. And I'm going to add together the 3 and 5, the last two terms, to get 8, okay? So you could continue writing down the formula, but we can pretty easily, just by following the pattern, tell that f of 5 is 5, and f of 6 is 8, and the next one, if we kept going, would be 13, right? And then 21, and then, one really needs to, 34, and so on, okay? So finding those patterns, right, we have formulas, but we also just kind of use our brains and find patterns as well. So here is another one written with that part I don't like, which is the n plus 1. So I'm going to rewrite this to be an n. If I bump that to an n, this is going to bump to an n minus 1. And this is going to bump to an n minus 2. Okay, so I would pause and try this one. So this is a little different. To get the next term, I do 2 times the previous term minus the term 2 before it. So I have a 0 and a 1 already. So the next thing I have to find, I already have a sub 1 and a sub 2, is a sub 3. So I'm going to do 2 times the term before it, so that's a sub 2, minus times the term, or minus, not times, minus the term 2 before it, which is a sub 1. So we have 2 times 1 minus 0 equals 2. So if I'm going to do one more with that, like kind of baby step in the middle. 1 before it is a sub 3, 2 before it is a sub 2. So 2, a sub 3 is 2, and a sub 2 is 1. So 3. Last one we have to find, so I'm going to do 2 times a sub 4 minus a sub 3. So 2 times a sub 4 is 3, minus 2, so 6 minus 2 is 4. So we got 4 as our answer. Now, if you take a second to step back, this sequence, which sounds like, it's kind of a little complicated, is 0, 1, 2, 3, 4, and it would kind of continue with those whole numbers if you went through.